Hey, Topic Analyze Math and History, and we are going to take a look at probability in geometry. So, we have been learning about probability in the past, before the geometry unit even started. And what we found out is probability is basically calculating like what is going to happen if this happens, or if there are this many outcomes, what would probably happen. So with probability, the formula we've been learning in the past years or so is the number of stuff that we want, or the number of outcomes we want, the number of outcomes that we want. Like if we wanted to roll a 6-sided dice and we want to see if we roll a 2, that's what we want. And we have to divide by all possible outcomes. So usually, when you calculate probability, you are going to have a fraction. Like a 6-sided dice, if I want to have a 2 on a 6-sided dice, I get 1 over 6. There is a 1/6 chance I'll get a 2 on a 6-sided dice.
Activate my monsters effect! If I don't do something soon!
But with geometry, it's a little bit different. So what we see right here looks like a triangle. Yes, and what we're supposed to do is, if I randomly pick 2 points on this diagram shown right here, what are the chances of a segment appearing after I randomly choose a point? Well, just like probability, we're going to calculate all the possible outcomes this triangle can have as segments. Here's an example. Let's see what something works. Let's see what happens if it works. So, if we have AC, it's going to work because this and this is a segment. AB, however, is not going to work because they're not segments. So let's do it by alphabetical order. So AB doesn't work. AC, AD works. Here. AE works. So we're done with A. Now we can start with B. So we can say BC works. The reason why we can't say BA is because that's the same thing as this, which doesn't work. So we're down to much less numbers than we can. BD works along with BE. Imagine the segments as I go along. Now we start with C. What we can do with C is we can say CD, and we could also say CE. So there's one more thing that we can do, is we can have DE. So we have put all the possible outcomes for segments for probability. We have to understand what is the percent of it if I randomly pick 2 points that become a segment. 1 doesn't work. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 work. And there are 10 in total. So 9 out of 10 work. Or we can say 90% it will become a segment if I point out 2 points. Other times we can say is, if there is a target at this figure right here, and the entire figure is 7 times 6 as a rectangle, and we have this by 3, what is the percentage of it, the arrow, hitting A, shaded area. So if I launched a bow and arrow, what is the percent or what is the probability of it hitting the shaded area? Well, going back from our formula, P equals number of outcomes I want divided by all possible outcomes, we'll have to calculate both of the areas. So for the larger one, we get 42. 7 times 6 is 42 units squared. And the smaller one is 3, and it's a square. So 3 times 3 is 9. Therefore, we can say 9 over 42 of it happening, of the arrow hitting the shaded area.
I hereby propose a non-aggression treaty to end hostilities between our two kingdoms. Patrick, by signing this historic armistice, you have brought peace to our lands. May your kingdom prosper. Well. What are you doing? What about the treaty?
This treaty ain't worth the sand it's printed on.
Oh, is that so? Well, if you think you can take down this castle, my answer is bring it on!
We could also calculate that for probability as well. Finding the area of two objects and find out what's the probability of that hitting that shaded area. There's one more example where we can use probability, but this one's a really big problem. Imagine you are falling out of an airplane and you try to parachute. However, your parachute fails to deploy and you are gonna fall and you're gonna crash land. The thing is, you want to land in area DBC or angle DBC because that's where people put a bunch of trampolines there. However, you need to calculate the probability of you landing there. If you land here, you'll hit really hard on the ground. But if you land here, you'll bounce on one of the trampolines and survive. So what's the chances? Well, we have 48 and we have 32. If we add the two, we're gonna get 80. And remember from the formula how we can use probability as the number of outcomes that you want divided by all the possible outcomes. We can turn 80 into a fraction of 32 over 80. The thing is, that is not simplified yet because we need to turn it into a percentage or a simplified answer. Your math teacher is not gonna put a really good grade on your test if you never, ever simplify your answers. So you can simplify it to 16 over 40. You can do 8 over 20, 4 over 10, and finally 2 out of 5. 2 out of 5 is the most simplest answer as a fraction. But as a percent, 2 out of 5, you would only have a 40% chance of landing in DBC or 32-degree area. So that is one more way you can calculate probability. Let's see what happens. So that was a very hard fall, and I hope you are okay. I hope you survived it. And that is how we calculate the probability in geometry. I hope this video has helped you. Thank you for watching Tao Ping and Life's Math Industry. Like and subscribe!